Good morning, everyone. First of all, hearty welcome to Python Web Conference 2023. And I'm Nagesh Vinnakota, working as a software engineering manager at CapitalOne since 2016. And I have Gokul Prabagaren as a colleague of mine as a co-speaker for this session. Today, we're going to discuss about push button deployments in minutes, not months. So our journey in CapitalOne at rewards. So CapitalOne is a founder-led company with a unique culture that is driven by a strong sense of innovation and entrepreneurship. So CapitalOne is a technology company doing banking for good. So we are a leading American bank that offers a wide range of financial products and services to individuals, small businesses, and commercial clients. And CapitalOne is the first US bank to the fully transition from on-premises data centers to the cloud. It was a bold move that modernized the bank's infrastructure and improved scalability, flexibility, and security. It also showcases our commitment to innovation and leadership in the digital transformation for the banking industry. So we have given back to the community in the form of tech, and we have made significant contributions in this technology. So some of our contributions are primarily on Python contributions like a data compy and data profiler. Data compy is a tool for comparing data in databases and data lakes. So this tool supports multiple data sources, including SQL database, HDFS, and Amazon S3. And data profiler is another Python tool, and then again an open source solution which explains your data with the data profiler. And with the help of this data profiler, we will be able to learn our data and what's in your data as well. So we have also supported the community with various innovative initiatives, especially like we focused on education. We have a Coders program, which inspires the future generation by educating, mentoring, and empowering students to recognize their potential as technologists. Coda is another program, which is a pathway for all the non-technical aspirants to take up their tech career. Today agenda, we are going to discuss about like a state of legacy deployments, our evolution during last decade. And we'll be discussing about the foundation pillars. And then we'll be discussing about the pipeline evolution at CapitalOne. And we will be discussing about the standardizations across the enterprise that we have made that helped us to build a robust pipeline, and the kind of practices that we follow. Like we will be quickly talking about the shifting left and the kind of practices that we implemented as part of our pipeline journey. And finally, we leave the floor for the question and answers. So I would like to take go into the time back, taking you all of you to the time machine. So over a decade ago, we had a separate development team for developing software artifacts and a DevOps team for deploying these artifacts into production. And each of these teams had a different responsibilities. And although it worked really well for some time, but over we started like experiencing like a coordination issues between these teams. Like knowledge gaps between the engineers, lack of complete control over software. So where like a developer says that it's a feature, and a testing engineer, like DevOps engineer, treat that as a bug. And also it has further delayed in delivering the quality software to our customers, and eventually it is operationally high cost to maintain these both teams. And this is where like we started investing on our foundation pillars. So the first and foremost thing which we did was like adopting the Agile standards. Like, so in the past, like we have used the waterfall SDLC methodology in building the artifacts. So although it's a best practice for building the software, but it has its own limitations due to the fact that testing can happen only after development. It's very hard to find the defects at the early stage of the development. And also like once the software is built, only then development teams are kind of handing over to DevOps team. So there is completely a lot of knowledge gap. So and it's very hard for maintaining them even on the on-prem servers as well. So that is where we started like investing into agile practices. And the core concept here we adopted was like you build your own culture. So this is like giving developers the operational responsibilities has greatly enhanced the quality of the services, both from the customer and the technology point of view at Capital One. This enabled our developers to become more involved in the day-to-day operations of their software and systems. It also empowered all the developers to have the complete control of the software artifact that they are building. It has eventually saved tons of time of our developer efforts at Capital One. And we still follow this great practice, you build your own. And eventually, like we have started, gone heavily into open source, mainly to adopt the cutting edge technologies being used. This is a very crucial step as part of our foundational pillars, because it has enhanced the ability to explore the opportunities available and integrate, with our artifacts. And as we started our journey, we have gone to the cloud computing. So this is where, like, just to quick recap, like, we have made a public announcement on 2015 that we want to reap the benefits of migrating to cloud. And we have completed this journey in 2020. And it was a bold move, like, because most of the banking, it's because we are like a fintech based company. We want to ensure that we are following the right standards here and giving utmost security to our customers as well. So modernizing the bank's infrastructure and improving the scalability and flexibility and security has played a crucial role in our success. And finally, we have like conducted extensive research on cutting edge technologies available in the software market, analyzing them with the proof of concepts to determine the best DevOps tools are available for our developers should use to facilitate the DevOps journey. And it also helped them to find and build the software in a right fashion. After investing heavily on these foundation pillars, our pipeline naturally evolved. So this is not a like overnight journey. Like it took few months together to evolve, and naturally we have came up with two major aspects. One of them is standardization, and other one is like extremely benefiting, taking benefits of the shifting left. With this, I would like to hand it over to Gokul to cover the next set of slides. Over to you, Gokul. Thank you.
Thank you, Nagesh. As Nagesh was alluding previously, right? With the strong investment on our foundational pillars, by going all in cloud, so speaking the right developer tools, particularly on the DevOps end, and adopting agile methodology to ship any software, and having all the things done primarily using open source as well as you build it you own. So those are the foundation pillars, as Nagesh was discussing, has actually propelled us with our pipeline journey, right? You have seen one of the which we have, that is how primarily the things have been operating, where there is a development team which completes the build and then throws it off the wall, and there is an ops team which fixes them and maintains them with the production environment. Those things had its own kind of a flaw, right? So from there, we came a long way with terms of pipeline, right? So we started from there and we adopted all the things, and we invested heavily on our foundational pillars, and our pipeline also, as Nagesh was alluding, evolved. And the starting, we will get into the details of how that happened, but primarily the two major areas with that evolution we are going to focus is the standardization, and also what are the benefits we got out of that, primarily in the area of shifting left. Starting off with the standardization. So the journey of our CI/CD, right? You can see from this screenshot, we have been using the Jenkins, and you can see from the samples, like they are all custom Groovy scripts which are put on the Jenkins pipeline, right? You can see the issues with this kind of approach. And with any kind of evolution, there are baby steps you take, and then you slowly start running, right? Crawl, run, right? So similarly, like these were our initial baby steps, where our pipeline primarily was using a lot of custom Groovy scripts. That's our initial version of CI/CD, and those has, by seeing this itself, you can relate that they have kind of issues with that. The reason is it doesn't have reusability, as well as this kind of method you cannot scale it when there are hundreds of agile teams which are shipping business critical functionalities, right? Those kind of things you cannot put everything on their own pipelines, and those kind of things you don't really benefit by having some kind of customized things on their own pipelines, right? So that is where we started, and you can see from the screenshots as well. And we have actually come very far in our pipeline evaluation. I cannot really go back and gather any of this kind of custom Groovy scripts in our environment. So I just gave some samples. So that is actually the starting point where we started. And we realized that these are all things probably it's not sustainable because of reusable and scalable issues. So what has happened after the custom Groovy scripts is people saw this, and then they slowly started doing some kind of reusable libraries in the custom scripting, right? Where there is some kind of common functionality that is kept as a reusable library and then being used in the scripting. Those reusable libraries naturally evolved, right? That's the next destination is them getting into some kind of a framework. The framework on top of what our Jenkins provides, those reusable libraries is what we are terming it as framework. But what has happened is there are multiple frameworks we actually have adopted within their line of business or within the tech group, whichever they were supporting, or primarily more focused towards their way of shipping the code, focusing on specifics, where it's driven towards API driven tech stack, or it's more on the batch driven tech stack. All this kind of customization, each framework had their own positives and also some drawbacks, right? The frameworks were doing more specific needs for their own things. This, if to listen to the sound of this, it's all similar things what we had with the custom Groovy script, right? We evolved, but it still had more specific things geared towards whatever they have been doing. The main problem with this is we are not still reaping the benefits of the wisdom of the crowd, because the engineers are doing a lot of things and that was not getting shared across. And also because we have been evolving in our CI/CD journey, the pace in which we were doing, and also the place where we started, the number of stages we wanted to really use in order to qualify a particular commit is ready to go to prod. Also evolved. When we started, we had maybe a limited number of stages, but over a period, those stages also evolved. So due to this evolution, we are not able to keep up with this various framework, because one framework probably was using 8 stages, the other framework probably was using only 6 stages. So those things all combined, we decided within our organization, there was a decision made. We wanted to make a declaration that all these pipelines has to converge at one point. So we cannot do this customized things across various frameworks. So we decided within the framework which one was offering a lot of reusable functionality, which has a less portability from others, right? So then we decided and pick one of the framework as a unified framework that has to be adopted across the enterprise, and others have to converge. So that convergence happened, and there was a winner, and we did have one of the framework which mostly ported all these things into them, and all the other lines of business or any sort of frameworks actually converged, and we started using this. By this, we were able to directly establish the standardization across our enterprise. This is the starting point of our standardization journey. So what it naturally provides is now the teams doesn't have to do any kind of a custom logic for them, and they all are going to operate in a unified fashion, and the knowledge also is pretty much shared. So if the particular customization a tech group requires, they build that functionality and then they just port it as an inner source component, and others also benefit out of that. So that is what actually majorly helped us, because you don't need to really keep reinventing this, particularly for your needs. Instead, you contribute that back to the standardized pipeline, so others also benefit, and this greatly reduces a lot of the things which many other teams actually have to do, that puts down your development cost. And also you can greatly ship all the code, whatever you need to production and deliver business functionality, which has actually propelled us to ship critical business functionality in a rapid speed. So this is what actually the standardization, establishing a standardization will greatly provide to any organization. Instead of doing some customized things across the spectrum of your pipelines within the enterprise, you adopt a particular standard framework in which everyone has to operate, others has to converge. That mindset will greatly benefit even the others. So you bring down the cost of development and use that for your customers' benefit by shipping business critical functionalities. This was one of the first things we were discussing, the standardization, and by adopting the standardized way of doing things in our pipeline, right? So we were able to adopt many great things in our pipeline, but today we are going to majorly focus on the shifting left part of it. Like just quick glimpse on the shifting left. Like Nagesh was also touching upon briefly on the. So if you are waterfall SDLC, there is a development phase, and you ship the code to your staging or pre-prod, and the testing team waits for that, and then they test your code. So there is a pace in which there is a waiting period for both of the teams, right? So the major disadvantage with the other way of shipping the code is you identify the bugs somewhat closer to your production, right? With the shifting left, we are pushing that more closer to the development phase. The pace in which these things are identified, where majorly the difference is. You try to identify as much as issues, vulnerabilities, whatever call it, those things closer to the development phase is what shifting left in general means. So with the heavy investment on our foundational pillars we were discussing previously, going all in agile, adopting cloud, best DevOps tools, and you build it your own culture, all these things actually has helped us to propel this journey of having standard pipeline. And two main areas we are going to discuss with respect to shifting left is security, and also how we are leveraging that for our automated functional testing. Before we go similar to what we have been discussing, right, a decade ago, how we were shipping. So from there, right now, pretty much 90% of our software deployment is even greater extent, it is automated. Out of that, closer to 70% are all on this standardized way, right? So that we are very close to achieving that to 100%, right? So this is the primary way all our software is getting shipped. And the two areas where we are going to focus primarily are security and also the functional testing. To start off with, we'll get into the security and how we are leveraging shifting left in terms of security. And this diagram just gives you a glimpse of how a daily a developer operates in our engineer operates in our enterprise, where typically there is a business feature which is getting developed, and that is there is a timeline in which that gets ship to production and customer realizes the benefit of that functionality, right? So developer starts off doing some development on their feature branch. That code, whatever they are developing, that even doesn't go to feature branch. Before that itself, we have enabled, there are ways and means in which the code, before even reaching the feature branch, we do have a lot of scans which are enabled to happen in their local environment itself, which is more closer to the development phase, where before they check in, they can just do some kind of scan for be a container, right? You can ask for the images, whatever the vulnerability it has, and also OSS, static, even open source, everything we can actually do in their local machine itself before it goes to the feature branch. So that we can identify even with the logic which is being put in there, is there anything with respect to security we are seeing, right? Though we immediately address that before even going to the dev branch or the feature branch where the developer is trying to get the first step, right? So this greatly benefits with respect to the time and also the cost involved to fix these issues if it happens in the later stage of the cycle, right? So once we clear all the things in their local machine, then get into the feature, we have enabled our pipeline also to do the similar scans in various stage. So once it gets to the feature branch, the similar scans which happens in the cloud in our pipeline, before it gets to the staging, pre-prod kind of environment, the same scans are done. Then we take it from there. Before we really put into production, the same thing is done. So the place in which this happens, the phase, this too is where it differs, but we are trying to get this closer to the development phase. And once we clear all these things, we qualify that particular commit is ready to go to production, and then that's when customer realizes this. The operation is cycle of this can be different for different kind of features we put in, but comparatively with respect to how we have been operating maybe a few decades ago, but now these are all things we greatly have reduced, and we are able to do this in maybe in minutes now. So this is the first area with respect to the shifting left, how we are greatly benefiting from our investments, right? The second area with respect to the shifting left is in terms of automated functional testing, and my friend Nagesh will take it over from here.
Thanks, Gokul. So as Gokul said, like earlier, like both security and automated functional testing are the crucial aspects of our pipeline journey. So if we take a step back, we also kind of perform like a lot of threat modeling sessions, which enhance to identify the security vulnerabilities at the early stage, and as well as this helps the developers to build, to come up with all the scenarios that are essential to as part of automated functional scenarios. So how, because each artifact has its own nature of testing. So the first, we have like identified few key steps that every developer has to follow as part of like this testing pipeline. So as Gokul shared in the previous slide, the framework pipeline is pretty much same for both security and functional testing, where the developer is actually like kind of forking the project and kind of running all the code and everything. After that, the first step he has to make sure is that the functionality is working as expected. So once the code is ready to check in, like before he commits the code to the feature branch, in case of like a microservice kind of deployment, he will be given the ability to test this functionality with a Docker image. So just to ensure that the functionality is working as expected, so he has to build an image and test the functionality in that Docker image with the Docker image, and then like deploy to the next further environments. Likewise, few projects will be using like a JUnit framework. Few projects will be using like Cucumber functionality testing. So the goal here is like conducting the threat modeling session at the early stage, identifying all the scenarios and finding the right testing automation framework to integrate into this pipeline. So once we choose this automated testing framework, the next step would be like, writing the automated tests. So as we discussed earlier, like you build, you own, like engineers at CapitalOne have the complete ownership of writing these functionality tests and integrate them into the pipeline. This will help us to build a robust and reliable software release process. And it also gives that complete awareness on that component as well for the developers. So once the engineers write automated tests, so as Gokul said, like it's about like more of integrating that as part of the pipeline. So here the challenge is like, when we run the pipeline, it went through the various stages after doing the security scans at the early stage. And if it fails through the security scans, the pipeline breaks there. If it passes through the security scans, the next step would be like, deploying this application to a environment and running the functionality tests. So if the functionality tests are working as expected in the CI/CD stage, it will continue further. Otherwise, the pipeline will halt there itself. Finally, it will also give a kind of a notification, like if the functionality testers are passed, the pipeline will continue to the next stage. Otherwise, it will kind of send a notification to the developers that the pipeline failed with so-and-so reason. So this actually ensures that the issues are caught really at the early and resolved quickly. And also it also helps us to improve the quality of software at the early stage rather than, identifying them after releasing it into production. So these are the two primary aspects that we have integrated as part of our pipeline journey. With this, by doing all these integrations, we were able to achieve the pipeline deployment into production within minutes, not in months. So, and I believe like companies who started are undergoing the similar journey, they can adopt this concept and they can continue their pipeline journey. Over to you, Gokul.
Yeah, some details about me. I'm an engineering manager at CapitalOne, and I have been building software from the initial versions of Java and Spark. And I regularly contribute to CapitalOne tech blogs, mainly in the areas in the big data processing. I have provided my social handles, and if you're interested, you can hit me up. Nagesh.
Yeah. I am Nagesh Vinnakota, engineering manager at CapitalOne. So been leading teams with building full stack software applications. You can follow me on LinkedIn and Twitter. Thank you so much.